Yeah. Um, so for today and tomorrow, I think I will finishing the polar and uh, parametric. So um, if everything's going fine, then maybe next week we will have a quiz. Okay. The chapters will be the trigonometry, including the unit circle, analytic trigonometry, and the polar. Yeah, polar. Okay. So for today, I will focus on um, how to graph polar curves. Okay. So one example of polar curve is if you see this r equal to sine theta. Okay. Obviously, there's no other variables. It's only the radius and the uh, theta. Then you can use this how to say that polar line coordinates, because okay, remember that the polar coordinate is actually in different world than the xy coordinate or the rectangular coordinates. Okay, so in xy you are looking at the two-dimensional, like having a square, right? But in polar, everything is like the line in a circular motion. Okay, they are in a circular motion. So if you have, for example, in this first line here, which is our baseline, it's the zero. This our starting point. Every time we draw the polar, we start from zero, and then we start increasing the degree, the radians. Okay, so if you want, okay, you can check the r to sine theta as theta maybe going from zero and then one circle, full circle until 2 pi. Okay, what will happen? Okay. And maybe let me make one here, because the sine theta max at 1. Okay. So if this one, maybe 1 also here. Okay. So what will happen? If your sine theta start from 0, the theta 0, then it start from here, right? It start from here. Sine theta is 0 here, right? And then you keep increasing. Um, this is pi over 6. Pi over 6 is what? Sine pi over 6, half, right? Half, right? Half. So if half, then it should be 1. So it's starting to get 1 here. Okay. And then pi over 4, do the same thing. It has square root of 2, right? So maybe a little bit uh, slightly larger, maybe here. And do the same thing. You will notice that um, or let me just go straight to the yeah, more or less it should be a symmetrical circle. Okay, so it should be a circle like this. Okay, so 2 sine theta will make a circle around here. Okay, if you make another polar curve with, let's say, 2 cos theta, let's say 2 cos theta, the cos will be here. Okay, if you try the angle 1 by 1 and try the point by 1 by 1. Okay, that's how you draw the polar curves. But eventually, okay, eventually The polar, they will have characteristics. Okay, I will go directly through that characteristic instead of trying one by one drawing the curve. You can do it on your own. Okay, I believe in you. You draw the curve. Okay, but I will go straight to the what is the characteristic and how many polar curves we have. Okay, and those polar curves will be useful in next semester in your calculus 2. Okay, so calculus 2, you still deal with the derivative integrations, but the shape is not only xy but also polar. Okay. Or let me give you another example for drawing and see whether you can make some conclusion or not. Okay. Uh, Consider, let's say we have now it's 2 theta, 2 theta. So r is equal cosine 2 theta. Okay. Can you try imagine what the graphs looks like? Cos 2 theta. Okay. By implementing the same idea from the polar. Okay. And remember, because all the contents here, all is polar. So do not try to make this into xy axis. We already moved from xy to polar. Okay. Because sometimes we confuse x, y, and polar, and you combine them together, and that's not good. Okay, that's wrong way. Okay, so try to draw the polar curve for the cosine 2 theta. And you can just using the special angle value, just using that. That's uh, enough for drawing these curves. At least what it looks like roughly. It's not a circle. It's not a circle or ellipse. No, not ellipse, not circle, but it's a something curvy. You can try, for example, you can try from 0 and try pi over 6, pi over 4, pi over 3, pi over 2. See what it looks like. And if you want to know details, maybe you want to know the not only the special angle, you can try also. If you have pi over 6, pi over 4, try in the middle one. Any angle here, or any angle here, any angle here. To prove the drawing is correct. So again, the cos 2 theta or sine 2 theta, it will not be a circle, not a circle, not a circle. Yes, correct, correct. Anyone find? At least what this looks like. Bikin ini ngerti nggak? Ngerti pindahin ini dari sini ke sini pindah bisa. Titik-titiknya ya. Nggak mau belajar lagi ya. Saya nggak bisa ngajarin lagi dari dasar. Saya pindah-pindah titiknya bisa. Bisa pindah-pindah titiknya. Pakai cos 2 theta. Okay, so first, okay, before we go to the cos 2 theta, let's review this circle first, okay? How I get this circle. So first, start with this line, the baseline, okay? This is how you are moving your angle, okay? The base, okay? Okay, at theta 0, for the circle, okay? Circle is what? The sine, this 2 sine theta, okay? So we back to 2 sine theta. So sine theta, sine 0 is 0, okay? So this the point, okay? And then let's say pi over 6 is half sine pi over 6. Sine 30, half. Yeah, trust me, it is half, okay? You try to, oh, sine 30, cos 30. And if you want to memorize just sine or cos, and then it will be complement. So sine 30 is half. So cos 30 is square root of 3 divided by 2, or half square root of 3. Okay, got it? Got it? That's very basic. Okay, if you mess up with that, I cannot help you. Okay, so it should be the circle should be this point here should be 1. Okay, I'm mentioning 1 here, but it should be, yeah, the circle should be crossing the 1. Okay, but just focus on the figure. And pi over 4. So if this is 1, this is larger than 1, right? Pi over 4 is square root of 2, right? Half square root of 2, sine 45. Sine 45, okay? So sine 45 is half square root of 2 multiplied by 2, it's square root of 2, right? Because this is the r2 sine theta, okay? And the easy one here, pi over 2 is 1. So this is 2. So this and this should be twice as this. Okay, it's not really that proportional, but this whole diameter should be twice this line. Okay, so that's how I got all this point. You can check every angle if you want that it's increasingly proportions to the circle. Okay, now we change the equations from these 2 sine theta, okay, change to cosine 2 theta. And with the same implementations, we try to make a new polar curves from this cosine 2 theta. Okay. What's your graphs looks like? Yeah, good. Okay, one student got right. Can you tell these students what this looks like? Yeah, like a flower with 4 petals. Okay, so it would be like, let me draw. So it will be like this, and this, and this, and this. Okay. It should be symmetry, but it has a 4 petals. Okay. And how you make the 4 petals? Okay. First, think the graph again, not in xy. If you're still confused, you're still thinking in xy axis. Think now as a polar curve or polar coordinates. You start from here, and it's starting increasing, increasing, increasing in angle. Okay, so in every point you will have a different point, and the point will make this we call the rose curves or rose petal curves. Okay. Okay. Now, I hope you can review it later, how you deal with the graphs for the polar curves. Try every angle you can find. So this is 0. If this is 30, 45, 60, try 15, try 10, try 20. What's the value? And put the dot on the each line. Put the dot there. Okay. And what the graphs looks like. Okay. If you have the the cos 2 theta, it will be having these petals. If it's this cos 4 theta, imagine it will be, I think, 8 petals. If it is 6, it will be 12. There's a pattern. Okay, I will tell you later. But for now, try to concentrate on how you are putting your point, okay, in the curves. Because if you don't know the characteristic of the polar, what you can do is just plotting the point. That's the thing that you can do now. Okay. Okay. Now, okay. Now I will go back to the R, and let's start from the cos theta. Okay. So A is it can be positive, it can be negative. Okay. So I will draw the graph. Um, it may look like X and Y, but it's not. Okay, it's not XY. It's not XY. I will not naming this XY. Okay, this is just for helping to draw. Okay, the polar curve is not based on XY. Okay, so a cosine theta, as I mentioned, it will have like the circle. Okay, so this if uh, if A positive, we will go here. And if it's negative, it's on the left side. Okay. Okay. And this will be A. This also, the distance also A. This will be half A. Okay. And this should be the negative A. So that's for cosine. For sine, as we draw before, it will be having this. This on the top side. Okay. So for cosine, it will be right or left. If you have A cosine theta. If you have A sine theta, it will be top or bottom. Okay. This if it is A positive, and this is A negative. And the distance is A. Distance is A. Okay, so start from A cosine theta and A sine theta. And what will happen if R is A? This is your circle at the, so it's centered circle. Okay. Let me give you the title for the first one is circles, circle and spiral. If you have R and then A multiplied by theta, this will be a spiral. And remember that I think at the beginning of the course, I talked a lot about the golden ratio. Yeah, this is the golden ratio will be occurred in the spiral. And you can see also the golden ratio in snail, the shell of the snail. Also, you can use the golden ratio for taking photo, making the object more focus and emphasize the specific object. Okay, those are spiral. Okay, I think the circle is not too crazy. I will give you the crazy one. We call this limaçon. Not sure. Is it Latin? Limaçon? Is it Latin? Spanish? Not sure. Or yeah, I'm not sure also. So it's called limacon. Is it Spanish? No, no, right? Or maybe French. Yeah, the C should be. Yeah, yeah. They have this limaçon. Uh, the property or the general equation will be R. Let's say A, the constant, plus minus B sine theta, and R also A plus minus B cos theta. So we have two. Okay. Uh, the sine and cos in any polar, okay, like in limaçon, if you remember, the cos will be left or right, and sine is top or down. It will be also the same characteristic. So if you have limaçon, sine or cos will they will have different sides. So sine will be, if not top, then down, top or bottom. If you have cosine, it will be right or left. Okay, but what is look like? Okay, what is look like? Let me draw. Um, Okay, that's the limason. So this is called limason with inner loop. It should be a little bit wider, but here the important thing is you have the loop in the inner side of the curves. Okay. So limason with inner loop will be occur if this will occur if a over b is less than 1. Let's say we have r is 3 plus 4 3 plus 4 cos. Let's say it's cos. So this is a, this is b. So 3 over 4 is less than 1. So that's why it's inner loop. And how we decide the point here, here, here. This is the 3 important points in the limason. Okay. This point here, let's say this is our curve. Okay. This point here is 7. This point here uh, should be proportion, but it should be 4. And the point here should be -3. It's 3. So the point 7 is the a plus b. Okay, a plus b, and this should be the 4, and 3 should be the a. So this should be b. Oh, wait. Uh, Not 4. It's correct. The proportion is correct. It should be 1. So this should be the a plus b. This should be the a minus b. But it should be having absolute value. So the difference between b and a. And this should be a, and this should be negative a. So this is the first one for limason. Let me draw several limasons, the other limasons, and then we can try some examples. So 2 is we call the cardioid. This is if A is B. So it's the same limason. Let me copy all this. So do you know cardio? Cardio, the heart, right? So it looks like a heart. Okay? So without the inner loop. And this will be the A plus B, and this should be A and minus A. The third one is the dimple lemmason. So it's similar to cardio, but the side uh, so the difference between the cardio and the dimple lemmason, the cardio it's sharp. This like the middle part is more sharper, but dimple is uh, more blunt, right? It's not really that sharp. Okay? This is if A is greater than B, or A over B greater than 1. We have the fourth one, but it's not really frequently occurred. It's called the convex lemmason. So it's like a circle, but it's not circle. Okay, so it's from here it's like a circle, but in this side it's getting dimpled, but not as dimpled as the second one. Okay? Um, this is if A is greater or equal to B. But this should be the same. This is the distance of A plus B. This is also A plus B. And this is A, this is minus A. This is also the same. Okay. Okay, now how to at least make all these polar curves logical. Okay. The idea is these two equations here. Okay? If you have any equations using sine or cos, and you are having any constant plus or minus constant and sine or cos, then the curves, the polar in polar, it should be Limason. Either it's dimpled um, with inner loop or become the cardioid, it's still Limason. Okay, and how to draw? Okay, how to draw? If you have like 3 plus 3 sine theta, so you have 3 3. The A and B is the same. It should be the cardioid. This should be the cardioid. Okay? If you have the same A and B, and how to make this distance? So how to draw? At least roughly, okay, roughly to draw. At least the distance here is always A plus B. The far distance is A plus B. This distance, if you're drawing not really that perfect, then just draw, make like a heart, and that's the cardioid. This kind of drawing, it can be helpful. For example, if you have integrations, you need to calculate area under the curve, and your curve is like this. How to do okay? How to calculate the integrations? You can calculate the integrations from, you can figure out which angle you want, depends on the case, until which angle, maybe from 0 to pi over 3. And maybe you have this and maybe another curve, maybe a circle, and you need to find the area in between. It can be the questions for integrations. Okay, so imagine any for this curves, usually it will be useful for the integration. If you have the polar curves and you need to integrate that, and you need to find the intersections, maybe this is a circle with sine or cos, then you can first find the intersection and then find the area under the curve here using the polar. But again, if you are talking in polar, all the perspective in x, y should be shifted to polar. You will know when you arrive at these chapters. Hmm? Yeah. Yeah, yeah. As long as it is having uh, key points that you can find. For example, the A plus B, it's easy to find, and A is easy to find. Yeah, I think that's the important thing. Yeah. The other, it's not too important. It's not too important. Yeah. Okay, uh, we are now the Limason, and tomorrow I will go finishing the rest of the polar, and maybe uh, going to the parametric equations. Okay, parametric equations. It's not too long. I think we can I think we can finish tomorrow. I think. If not, then the quiz is not next week, but next 2 weeks. Okay. 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 I think that's for today.